At the relationship between our parametric equations and our velocities, and finding objects, where they are at different times and all of that stuff. What we want to look at now is an application of our parametric equations and velocities and finding a location where an object is the closest to us. Okay? So when we have some moving object, like the one you see here, moving from A through the point R, and we're standing here at point P, we can figure out where along that path is the closest point. Let's say these are our friends, and they can't come any closer than this to the shore, and they're out on their boat, and we want to join them, okay? So we're going to swim out to where they're at. Well, I would rather not swim any further than I have to. So where along this path would be the closest point? Just logically speaking, how? Straight across meaning?
Perpendicular.
Okay, there we go. There's the key there, perpendicular. My path to the line would be perpendicular to the line. That's the key to this whole unit, this whole section here. Okay? So here's what we're going to do. We're actually going to take this R, okay? And R is just any random point on the line, okay? We're going to make that R be wherever that perpendicular would hit the line, okay? We actually call that the foot of the perpendicular, all right? Now, let's look at the guiding principle here, and let's see if you guys can figure it out. If I want to be perpendicular to the line, what do you think I'm probably going to use? Our whole unit is on what topic? Vectors. Okay, so when you hear the word perpendicular, you're thinking orthogonal. Okay, and how do we get orthogonal? The dot product equals 0. Okay, the dot product equals 0. So here's what we're going to do. We need to figure out some vector PR. And we need to identify the velocity of the object that's going along this path. And then we need to force the dot product to equal 0 so that we know that R is the foot of the perpendicular. Okay? Now that sounds like a big task, but it's actually easier than you might think. Okay? There's a method to this that is basically the same for all of these. Alright, so let's look at that here. Here we have a line. It has the vector equation xy equals 1, 2 plus t times 3, negative 1. And t is a real number. Let point P be the point 5, negative 1. We want to find exactly the shortest distance from point P to the line. Okay? So, first of all, what I want to do is I want to actually look at this. Okay, so we have this graph, and the reason why I want to look at it is because we can actually get a ballpark idea of what our answer should be just by eyeballing the situation. Okay, so if I were to plot my point, the point 5, negative 1, I'd be right here. Okay, there's my point P. And then if I look at the line, it starts at the point 1, 2. That's when t equals 0. All right? And then my velocity is 3, negative 1. That means I'm going to the right 3 and down 1 every time. Every 1 unit of time. So over 1, 2, 3, down 1. Here's where t equals 1. I go over another 1, 2, 3 and down 1. And that's where t equals 2. And my line is just going to follow that path, okay? Now, we can't get an answer this way, but we can anticipate about what the answer would be. Notice here, if I were to go perpendicular to the line, this would be approximately perpendicular here. About when is that going to happen?
1.5. T equals 1.5.
Yeah, somewhere between 1 and 2, right? I can reasonably say that it's probably going to happen between 1 and 2, maybe around a 1.5. We don't know exactly, okay? And we can say that it's probably going to, the y is probably going to be between 0 and 1. The x is going to be somewhere between, 4 and 7 here, okay? So now we have an idea of what our answer ought to be. And that's important, guys, because it's really easy to make a little mistake and then get an answer that's totally unreasonable if you actually looked at it, okay? So now that we have in our head about what our solution should be, let's look at the 3 key parts to this, okay? What are the 3 key parts for this? First of all, we need to define the point R, okay? And every time we do these, we're going to define R the same way. All right? R is going to be the point whose coordinates are, in this case, 1 plus 3t and 2 minus t. Where did I come up with those? The parametric equations. Okay? You're using the parametric equations to represent some random point R on the line. Okay? Does everyone follow what I just did here? That's a key step you've got to remember. Okay? Because this line has this equation, the parametric equations are x equals 1 plus 3 times t and y equals 2 plus t times negative 1, so 2 minus t. That means every point on this line will have coordinates that relate this way to t. So I'm just naming some random one r, and I'm going to make that be the foot of my perpendicular. Okay? Now, in order to do that, we already said we're going to do a dot product equal to 0. Okay? So R is going to be this point here. And what I want to do, the dot product that's going to equal 0, okay, because we want to get this perpendicular to the line, we're going to find vector PR. We're going to dot it with what?
The line.
What?
Line.
Well, what about the line? You're right.
Yeah, velocity.
Yeah, what is determining the direction of the line? It's that velocity vector. So in this case, that's 3, negative 1. Okay? And we want that to equal 0. Okay? So that's where this second key point comes in. All right? Find the vector PR. And this is where knowing that formula for finding the vector between 2 points can be helpful. All right? So let's find vector PR. Okay? For vector PR, we take the coordinates of the point you're going to, which would be the parametric equations, 1 plus 3t and 2 minus t, and then we subtract what?
Start where we started from.
The coordinates of the point we started from. So point P was 5, negative 1. Okay? That's kind of the second real key aspect of this you got to remember how to do. You're finding the vector here from the point you know to this random point. Okay? So now we simplify that, and it's a negative 4 plus 3t, and that's a 3 minus t. And now we know what vector we need to dot here with 3, -1 to get 0. Okay? Is there any part of this that we don't understand? I want to make sure everybody's with me on this. We got it? Okay. So now it's really just a matter of, we've got our equation, we just have to solve it. Okay? -4 plus 3t, 3 minus t, dotted with 3 -1 equals 0. Make sure you do your dot product carefully. Okay? It's 3 times -4 plus 3t minus 1 times 3 minus t. Okay? Equals 0. And now you're back to pre-algebra equations. Okay? So. So t does actually equal 1.5. Okay. T equals 1.5. And now look, it says find exactly the shortest distance. Have I answered the question or answered the problem here? Not yet. I've got the right time. But this is where we go back. Don't quit too soon. You did the hard part. Now it's just the easy part. Okay? So now we plug this time in. This is, PR is the shortest vector. Okay? So we plug that in and we get 4 plus 3 times 1.5. So that's -4 plus 4.5. So that's 1/2. And then 3 minus 1.5 is 1.5. Okay? So have we answered the question yet? That's the vector that we
magnitude.
find the magnitude. Good, good. Again, we've done all the hard work. Don't forget to answer the problem. So it's 1/2 squared plus 1.5 squared. So that's 0.25 plus 1.2, or I'm sorry, 2.25. So this is the square root of 2.5, which is going to be square root of 10 over 2. Okay? That's the shortest distance. Square root of 10 over 2. So there's a lot of steps to these. You gotta just stay organized, take it one step at a time, and there's certain things you do have to remember, but that's why we practice. So you just get some experience doing this over and over and over again. Okay? Alright, now, I want to take it one more step, okay, and actually apply it to a situation. And there's 2 elements to this. One is really, really easy, and one we've already talked about when we were going over the homework. Okay? So, here it says, on the map, distances shown are measured in kilometers. Ship R is moving in the direction 3-4 at 10 kilometers per hour. Okay? Write an expression for the position of the ship in terms of T, the number of hours leaving port A. Okay? So, here, the ship is leaving port A, which is at the point -8.3. It's going this direction. Alright, so what would the position of our ship be? Let's get an equation.
-8.3 plus t
We've done this a lot. Okay? So, negative 8, 3 plus t times 3, 4. And that's going to be the position. Alright? So now, here we are over at the port, at port P, which is the point 10, 2. So when is this closest to where we are? In other words, where will that, or I should say, when will this be perpendicular to the path the boat's taking? So what are we going to do?
Make the product do 0.
Dot product equals 0, right? Dot product equals 0. What are we gonna do first? We don't have another vector here yet.
Find R.
What's R? Come on, guys. What's R?
It's
At this point, we're doing exactly the same thing that we just did. Okay, R is the parametric equation. So R is the point.
Negative 8 plus 3t.
I should put equal. I should just put parentheses. Negative 8 plus 3t. And the y coordinate is 3 plus 4t. Okay? That's R. So vector PR that we want to dot with the direction that the ship is going is what vector here?
it's 10 plus, so 10 minus 8 plus 3t.
Okay? And I'm going to turn it around a little bit just so we don't have to distribute negatives because we'll probably forget. Okay? So there we go. It's R, coordinate of R minus the coordinate of P, and then the y coordinate of R minus the y coordinate of T. Okay? So, negative 18 plus 3t. 3 minus 2 is 1 plus 4t. And now we have our vector. And we want to dot that with what other vector? 3, 4. Okay? 3, 4. So, negative 18 plus 3t, 1 plus 4t, dotted with 3, 4. We want to force that to equal 0, so we're going to solve t. Okay. Negative 54 plus 9t plus 4 times 1 plus 4 times 4t. That'd be 16t. And again, we got an easy equation to solve. 25t equals 50, so t equals 1/2. Okay?
It'd be 2.
2, yeah. There we go. So t equals 2. That's our time. Okay? Now, one thing here that we have to be careful with. That's our time using this as our velocity. What is the speed?
10 kilometers an hour.
Yeah, the speed is this. What's the speed of the vector that we used?
10 kilometers.
Now look at 3, 4. What's the magnitude there?
5 kilometers an hour.
5, okay? So the magnitude of 3, 4 is 5, okay? Which means this is only going half as fast as the boat actually was going, which means our time is what?
It's double.
A half of what we got. If we were only going half as fast, it would take twice as long, right? So we need to cut our time in half. Alright? So even though we got a t equal to 2, it would be 2 hours going 5 kilometers per hour, but we were going 10 kilometers per hour. So it's only going to take 1 hour going 10 kilometers per hour. Now, are we going to remember to do that? I hope so. Okay. However, one thing you could have done to kind of adjust this from the beginning, how could we modify this direction vector so it is the actual velocity vector?
Union vector,
What?
the union vector.
Okay, if we made a unit vector out of this, that would be 1 kilometer per hour. And then what would we do with the unit vector? Multiply it by 10. Okay? Now, if this had a magnitude of 5, how could we get to the magnitude of 10 just all in one step? Just multiply it by 2. Alright, so here's the deal. If I had used the vector 6, 8 here instead of 3, 4, I would have gotten t equal to 1. Alright? Either way that makes sense to you, either adjust your direction so it is the velocity, okay, or just make sure you interpret your answer at the end properly. It's up to you which one you choose to do, okay? This is where you've got to pay attention to the language, okay? If they tell you it's just the direction, it may not be the right speed, okay? If they tell you it's the velocity vector, then you know that's my velocity vector. I don't need to worry about any of that, okay? So I know it's a fine detail there, but we got to be careful with it. All right? All right, I gave you some practice to do for tomorrow. Just 3 problems, work through them, take the time, make sure you understand, okay? All right. Have a great day, guys.